share my screen. I hope that you can see it right now. So yes, very happy to be here on stage. Like Gleb already introduced us, I'm Felix, Senior PM, joined by our tech lead for data, Jorrit. And yeah, we want to focus on how to balance technical alignment and speed with one practical example, which is automating our CI checks. So what's Fin? Gleb already pitched it pretty well. So we're building the category leader for what you call a car subscription in Germany and US. And our goal is to make driving a car as easy as any other subscription service that you use, like for cars or, like for movies or music. I also listed some advantages of our product. It comes down to a seamless e-commerce experience. So you're all paying a flat rate to Fin, and customers usually keep their cars for 12 months. So let's have a look at our data setup, because while Fin has grown to over 400 employees in nearly 4 years now, we've had over 35 DBT contributors last month. So we have quite a big setup, and we also maintain over 1,800 models right now. And we have quite a high Looker coverage as well. So the DBT contributors also serve our Looker content to more than 75% of the company. And this stack has pretty much stayed the same, right? So you see BigQuery, DBT, and Looker. But what has actually changed over the time is our organization. And it has changed quite a lot, with the main conflict being balancing the technical alignment and speed, what we want to focus on today. We call it the decentralization trade-off, and I'm happy to lead you a bit through our history here. So I want to compare our organizational setup on the right to the impact on the 2 dimensions it had on the left. So we started off about 2 years ago. We're pretty similar stack to the one you've seen before, and we actually started with a small central data team of 3 contributors. So we were easily fed by 2 pizzas, right? We had daily stand-ups. It was pretty easy to align any technical topics, so the code style was clear. Everyone knew what the other one was working on. And while this created great stable pipelines and clean code, it was quite slow because we were missing the business understanding in each vertical. So the whole process from ingestion to delivering Looker dashboards was pretty slow. And therefore, roughly 1 year later, we began building decentral data teams, so hiring analysts in each business function. And that, of course, helped to drive decisions very quickly by building anything from DBT to Looker in departments and generating business value way quicker than before. As you see in the diagram on the left, that came also at the cost of technical alignment, because you know the anecdote. So your lineage might look like a spaghetti meal. You also have ambiguous definitions of different dimensions, or teams could even cause unwanted downstream changes to other teams, which you, of course, want to prevent. And it becomes increasingly difficult to fit everything together and, for example, explain it to new joiners in your onboarding. So we also had countermeasures to that. So, for example, the central data team would review every change to the repo and also own core models, which adds some governance and also introduces some common standards in this organization. But putting an emphasis on those topics actually slowed down development again and created a lot of overhead. For example, communication, collaborating between the different teams, and also making these standards more explicit. So while becoming a bottleneck for making decisions again, so what you actually want to absolutely avoid when building data teams, we were thinking that we need to find a solution to break this frontier, not always have to compromise one or the other. And as you see, our contributors grew quite much to early 2023. So quite recently, actually, at the beginning of this year, we've asked ourselves how we can scale to even more contributors in the future and break this frontier that we encountered. And one solution from our toolbox were the automated CI checks, which is a pretty practical example. And Jorrit will provide you with an interesting deep dive on that.
Thanks, Felix. Yeah, let's now have a look on the technical strategy that we picked to get the both of both worlds, so technical alignment and speed at the same time. And it's mostly about GitHub Actions in combination with tools like Dataflow, DBT, tooling, and SQL Fluff. And the things that we aim to get from those tools are code quality, code validity, some alignment on the lineage, and alignment on other policies and a lot of standards. For example, the naming convention. And I will deep dive into all of those 4 topics now. The first one regarding code quality. Here the goal is we want every code file, so basically every DBT file, look the same. So whenever you pick up a DBT file you never worked on, you should be able to read it in a flow and in a style that you're used to. And on the left side, from a user perspective, you can see uppercase, lowercase code, indentation is not good. And all data practitioners can use SQL Fluff to basically fix most of those issues automatically. So to align the code style and get something like on the right side. That's how our DBT models would look like. And also, since this is also part of our CI, in GitHub Actions, so the bad deformatted code would not be able to merge. So we actually prevent or enforce this kind of linted and fixed code. Let's now go into the code validity topic. Okay, thanks. So yeah, I'm actually not sure how we would be able to work without data fault, because I don't know, we would be tremendously inefficient by this fear of, will my change break any downstream models, systems, pipelines? And what, like, during pull request, every data practitioner gets basically an overview and can really efficiently investigate the impact of that change on the model that have been changed, but also all downstream models. And that's super important because as we are growing, we are onboarding regions, we often restructure and refactor our code also way upstream. And we always need to know if any bigger initiative or also small changes, if they make some kind of KPI broken. And on the left side, you can see an example how this looks like in a pull request. So the data practitioner would get on pull request this kind of comment, and you can already see there are a lot of differing columns and rows. And then the person can open it, and on the right side, you would see in those bars. And if you have some kind of deviation in those bars, that means like before and how it would like after pull request. And if your code change cannot explain this deviation, you have a hint and you might want to jump back into your code and look if there's a mistake. And you get this basically for your change models, but also all downstream models. And you can basically really efficiently evaluate before and after. And that's really like something that we actually is super crucial to stay efficient and make changes like multiple times per day everywhere in the pipeline. And let's now go into the lineage topic. So regarding lineage, Felix already mentioned it, the spaghetti lineage. So we have some kind of data flow that we want to see, which we closely try to align with communication patterns in the teams and the org structure, bringing those aspects really close together, borrowing some principles from data mesh. And also here in the CI, we can basically check that this reference here in red, this would not be possible. So someone doing this in the code would not be able to merge into our DBT mono repo. And this is like super helpful in terms of, okay, we have this target lineage and we want to keep it, but also as soon as we have a new lineage or we onboard new regions or other bigger chunks of data, we can basically predefine the target lineage and then make sure that it's basically rolled out and followed across all decentralized data teams without communicating about it. It's just enforced during pull request. Okay, then we can go now into other policies. And here it's about naming convention, owner. So on the left side, you can see a list of checks that are run during pull request again, but also can be run on the local machines of the analysts and analytics engineers. So hard-coded references, owner tags, certain tests need to be in place. Then the column naming conventions, and so on. So we have a big list of changes of policies and rules that we think are important. And on the right side, you can see basically the configuration. So whenever we have something, it's basically at its core, it's a Python file that is executed on pull request. And we just have to basically hook it into or put it into this list of checks. And then on pull request, every changed file is checked to, that whatever we define in Python is according to what we expect and want to see. And this brings me to the conclusion. So all of this, like one thing to keep in mind here, at Fin, we basically have one central data team with the mission of making analysts more efficient. We even have a KPI for that, perceived analysts productivity. So therefore, all of those things are driven by our belief that one team should basically just optimize how the other decentralized teams are working. But this also means that you are actively investing into this. So the stuff needs some integration, needs some maintenance. Whatever rule you define in your pre-commit checks, you also will get a lot of false positives or false negatives. So there is some stuff to maintain, but we think this investment is really like beneficial, because what you get in the end is it's just like a multiplier. You get increased development speed across multiple decentralized teams. All teams are technically aligned without speaking to each other that much, so you can reduce the communication overhead tremendously. And also policies are made explicit. So whenever someone starts new, the person does not have to learn a lot of like a list of policies. It's just part of the merge request and the natural development flow, and people learn it by doing and running against a check, for example. And yeah, that's basically it.
Thank you so much, Felix and Jorrit. That was really insightful. Also, thanks for the shout out. I think what I really loved about your the narrative is that how you approach thinking about speed versus quality and technical alignment. And I think that in many times we think of this as trade-off, almost like we have to either ship very fast, but disregarding a lot of the proper ways of doing things like testing and quality checks and aligning on, you know, SQL formatting and column naming conventions, right? But I think what you've done really amazingly is kind of shifted the entire frontier, right? Just moved to a different frontier with regards to that trade-off. And I think it's a really, really powerful mental model to think when you're, you know, scaling data platforms in organizations. I would also encourage everyone to vote in the polls. I'm particularly interested in the topic of CI, because I think that a lot of the kind of best practices and solutions that we heard today from Emily and from Felix and Jorrit, they kind of depend on the ability to automatically detect and enforce things, be that, you know, column inconsistencies or any kind of data quality, you know, testing or impact analysis, and CI, which is the way to, you know, build a staging environment and run out those checks for every change that is proposed to be deployed as a really central process. I'm really curious how where everyone is with regards to implementing CI with DBT. I think there's a question from Christopher. How do you enforce rules where tables from reporting layer won't reference tables from the source layer, as in your diagram?
Yeah, we basically have naming conventions for the models. So the models follow a certain naming convention. So a model can be identified according like where it lives in the layer from its name. And therefore, if we have something on the source and something on, I don't know, dimension, and we know dimension is only allowed to reference stuff from integration, for example, we can just do this by naming and then having actually rather simple Python scripts and check the from statements and see if the from statements follow this kind of reference in terms of the naming conventions.
I think there's also a question about CI. How long does CI take to run for you? If you build, do you use Slim CI? Do you build the entire project?
We use Slim CI, so only changed and downstream models are built. And I don't have a number. I think like it's around 5 minutes, maybe 10 minutes, something like this. Rather 5. So it's not that huge.
Yeah, that's actually
we also
really
have
fast.
rather fragmented data and not like huge amounts of data. So again, I guess it will depend on your volume and so on.
Awesome. Yeah, also shout out to DBT Labs for building Slim CI. I think it's been like a really big efficiency improvement feature for implementing CI. In a nutshell, it basically allows you to reuse data from production when you make a change, so you don't have to spend unnecessary compute. Awesome.